Welcome, Velociraptors. Today we will be reviewing the nuts and bolts of completing an arthropod project in Planet Earth. Before I get started, please feel free to download this presentation to take notes on. You might also want to reference your organism handout, which is located in the Resources module on Blend. Let's get started. As an arthropod group, you will need some supplies to get started. First, you will want to ensure that you have reviewed the project packet and completed your notebook formatting for the field. You will also need a field guide and key, which you will use to identify the specimen you photographed in the field. This leads to your last supply, a mobile camera. Since you will not be collecting the specimens, you will need to be able to take a quality image of your organism. To do this, you will need something to take images with. A mobile phone is perfect, but any camera will work. Now that we have the necessary supplies, you will need to determine where you are going to study. Each individual needs to select 3 different parks to study. Start by first looking at the list provided in the Introduction to the Project presentation, which can be found in the Resources module on Blend. This means that as a group of 2, you will have 6 different parks in total. If you're a group of 3, then that would be a total of 9 different parks. If you would like to propose a park that is not on the list, please reach out as soon as possible so that we can determine if the chosen park is feasible for the project. Each student is responsible for their own 3 parks. This is one of the individual grading components of the project. As you are choosing your parks to study, you are going to want to take into account proximity and accessibility. You are going to have to think about what would you like to study. You need to be thinking about what physical variables might be feasible to study in relation to your locations. You might choose water availability, such as the park's access to water. It might have no access or border the Colorado River. You might also choose geology. You could study the impact of different soil types or rock units and their impact on abundance. You might also investigate the impact of urbanization. This might be how far it is on average from urbanization. It might be the distance from downtown. If those aren't working for your chosen study sites, you could investigate elevation by analyzing parks based on their average elevation. You will need to review your group's parks to determine which variable is more feasible for your group. For instance, if you choose elevation, it might look something like this. Each individual is responsible for a park with a high average elevation, medium average elevation, and low average elevation. This ensures that there is no biases associated with data collection. For instance, if the orange researcher was not the best and collected all the data at high elevation, then it might appear that a correlation existed that was just an error on the researcher's part. Of course, this is an ideal situation. This might not be possible given limitations. However, try your best to ensure to limit biases where possible. Now it's time to collect data. For this project, you will collect a majority of your data through the process of data mining. This means that you will not actually be collecting or analyzing the specimen yourself, but using already collected data. You will identify 2 specimens at each park that will count as a ground truth. This supports your data mining by providing a true specimen present in the park. These specimens will then be uploaded to iNaturalist so that you too can contribute to the community which you are using for the project. Together, we consider this as an entire data set, which we will complete 3 times during the semester. Let's dive a little deeper. The data you will be collecting is from iNaturalist. This is citizen science data. It has been collected by and identified by members of the community. This creates a unique environment for you to interact and contribute to your community. To get started, you will first need to create an account. Go to inaturalist.org and create an account. You can use this sign in with Google if you would like to link it to your Alston ISD account. Once you have created your account, you should see a search bar in the upper left-hand corner. Please search for GAMP Biodiversity. Then click Projects at the top to filter your results. Click the project that corresponds to your particular class section. Then click Join to join the group. This will add you to my group so that I can quickly access your post. Be sure to use a username that I can easily identify. If you are not comfortable using an identifiable username, please send me a message via the Blend inbox to provide me with your corresponding username. For each data collection, you will need to create a Google Sheet just like this. You can keep all of your data sets in a single document, but make sure that they are on different sheets. This helps me quickly assess your work. You will be recording the species name, number of individuals, which is the same thing as the number of observations, and calculating the relative density. To do this, you will click Explore and navigate to your particular park. You will then record all species that were observed in the park. As you can see, this can be quite a large population, 240 for this example. Don't worry about all the steps right now. There will be another video explaining all the details when you complete your first data set. You will need to calculate the relative density for each species. This is done by taking the total observations of a particular species divided by the total number of observations for The park times 100. This will be relatively easy using Google Sheets equations, but more on that later. In addition to mining other individuals' data, you will be collecting some of your own. These will be your ground truth points. You will collect 2 ground truth points from each park. This will be completed along with your data set. Since you will not be collecting the specimen, you will need to take stellar images that will be used to post your specimen to iNaturalist. Make sure to take at least 3 images of your organism. This should not be 3 identical images. This should capture the organism from different angles. I know that this might be difficult, thus I just ask that you try your best. The higher quality images you take, the easier it will be to identify the arthropod. You will also record this in your notebook. You will record the order. If you don't know what it is, you can write unknown A for now, plus the date and location. Ensure that you provide a detailed location that includes the latitude and longitude coordinates. Lastly, provide a brief description with a detailed scientific drawing of your arthropod. We've covered what you will be doing as part of the project, but we still need to talk about how you will identify these ground truth points. You have several resources to help you, such as an annotated Dichotus Key, an online field guide, the entire iNaturalist community, and your instructors for support. Let's take a quick look at this Dichotomous key that you will be using to help you identify your specimens. This key is two-sided, with this being the front page. To use this key, you will want to start at the top by asking your very first question. If you go left, then that indicates obvious and membranous wings, whereas the right would be wings absent or modified, such as folded over on the back and hard to see. Let's say we have a monarch butterfly. Then we would go to the left, which would lead to this side of the key. If we were to go right, we would need to flip this key over to the other side. We would then see our next question is about scales. Are the wings covered with minute scales? This is typically referring to the translucency of the wings. Wings with scales are usually not clear. This would be your typical butterfly. Thus, our monarch butterfly would be classified as Lepidoptera. If it did not have scales, you would keep following the key until you determine the order. Other things to note. You will see several orders that have been highlighted in red. This indicates that it is likely present in Austin, or its range includes Austin. The non-highlighted orders are less likely to be found here. In addition, if you look at Diptera, you will see the term halteres. This is the only order that has a single set of wings. Most arthropods have 2 sets of wings. To confirm this, you can look for halteres, which are the nubs that are in place of that second set of wings. Here's the back side of this dichotomous key, which contains arthropods without wings or with modified wings. All throughout the key, you will see these distinct lines next to each of the illustrations. This is to provide you with some indication of the size of the order. The line indicates the actual size. If an illustration has more than one line, then they add together to indicate the total length of the arthropod. Well done, Velociraptors. You've almost completed the Arthropods workshop. Use the skills that you have learned here and the resources provided to complete the following practice identifications. Please let me know if you have any questions, and thanks for tuning in.